Hi, this is Amit Kirti here. In this video, I would like to talk about Warshall's algorithm. So the items for discussions are Warshall's algorithm introduction, the Warshall's algorithm itself, the Warshall's algorithm example. Then we will look at the Warshall's algorithm using the same example, and then we'll try to calculate the time complexity of Warshall's algorithm. Now, Warshall's algorithm is actually used to find the transitive closure of a directed graph. Now, there are a lot of words here. We will try to see what it means. Now, this is a directed graph because there are vertices and there are directed edges. So, for example, from A to B, we have a directed edge. Similarly, from B to D. Now, we can write something called as an adjacency matrix out of this directed graph. Now, adjacency matrix will have a value 1 if there is an edge from those two vertices. For example, A to B is a 1 in this matrix because there is an edge from A to B here. Similarly, B to D is a 1 because there is an edge from B to D. So this is an adjacency matrix of a directed graph. Our aim is to find a transitive closure for this. Now, what do we actually mean by a transitive closure? Now, transitive closure is actually a n by n Boolean matrix where a value in that matrix will be 1 if there is a path from a vertex from I to j. So T of ij will be 1 if somehow we can go from I to j via single hop or multiple hops. So if this is my graph with the number of vertices and this is my adjacency matrix which just shows immediate edges, that is from A to B or B to D. So I have to start from this and then reach something called as a transitive closure, which looks like this, which will tell me can I reach from one vertex to the other via multiple hops through other vertices. So Warshall's algorithm helps you to start from adjacency matrix and reach the final transitive closure for the graph. So we will try to look at Warshall's algorithm using an example. So we have to start somewhere. So we start with this adjacency matrix R0. And what we do is, as a first step, we try to see if we can find new paths by hopping through some other vertices. In this case, I start with A as my intermediate vertex. Do I find any new paths? In this graph, we can see that there is no way I can reach from D to B directly, but I can go from D to A and A to B. So basically, in this step, I try to find such new paths, and in the end we will see that this is the only path we find in this iteration. Anyway, let's see that. So R0 is my adjacency matrix from which I start, and in order to get the answer, I'll take one more copy of R0, same copy, and this will be my R1 where I will store my answer. That is ANDing of values, and my answer should be stored here. So let's see, can I find new paths with A as intermediate vertex? So first I'll start with AA. Can I go from A to A via A? Now to do that, first I have to go from A to A, then from A to A. Now since both are zeros, there is no way to go from A to A via A. So this value will actually be a 0. Now can I go from A to B via A? I really don't have to go via A because AB is already 1. So I have an edge, so I'll simply write a 1 here. Then can I go from A to C via A? So for that I have to go from A to A and then A to C. So you see that there is no path from A to A, so and A to C as well. So I cannot go from A to C, so I write a 0. So can I go from A to D via A? So for that I have to first go from A to A, then A to D. Now A to A there is no path, neither is a path from A to D, so this value becomes a 0. Now can I go from B to A via A? For that I have to go first from B to A, then A to A. So B to A via A, there is no way to go from B to A, so this value becomes a 0. Now can I go from B to B via A? So for that first I have to go B to A to B. But B to A is 0, though A to B is 1, so this value becomes a 0. So can I go from B to C via A? In this figure you can see that for that I have to go from B to A and A to C. Both of them are zeros. B to A is 0, A to C is 0, so this value becomes a 0. Now can I go from B to D? Since B to D there is a direct edge, so I don't have to go via A, so I'll just write a 1 here. Now can I go from C to A? To go from C to A, I have to go first from C to A, then A to A. So C to A is 0 and A to A is also 0, so I cannot go from C to A via A. So can I go from C to B via A? That is also not possible because C to A there is no path, though A to B there is a path. So C to A is 0, A to B is 1, which really does not make a difference. So this value becomes a 0. Can I go from C to C via A? Obviously not, because C to A and A to C both are zeros. So C to A is 0, A to C is also 0. So this value becomes a 0. Can I go from C to D via A? For that I have to go C to A and then some way to reach D, which is not possible because C to A is 0 and A to D is also 0. So this value becomes a 0. Then can I go from D to A? D to A there is a direct edge, so I don't have to use A as intermediate vertex. So D to A it's already 1, so it becomes a 1. Can I go from D to B via A? So right now there is no way of directly going from D to B, but you can see I can go from D to A, A to B. So to go from D to B, first I go D to A, which is a 1, A to B is also a 1. So this is my first finding using A as intermediate vertex. I have found a new path from D to B, so I'll just make this as 1. Then can I go from D to C via A? For to go from D to C via A, I really don't have to take that trouble because D to C there is a direct edge. So D to C is already 1, so I write a 1 here. So can I go from D to D via A? For that I have to have a path from D to A and then A to D. Now D to A is 1 and A to D is 0, so I really cannot go to D from D via A. So this value becomes a 0. So this is my first iteration, and in this first iteration I have found out one path, that is from D to B. Next what I do is, with B as intermediate vertex, do I find new paths? Now for that what I do is, my previous calculation, that is R1, will become a new input because I have found out new paths. So I want to leverage on that to find out new paths. So this is a matrix with A as intermediate vertex. So if I take one more of this and try to solve R2 with B as intermediate vertex, my solution, that is this, will have new paths with both A and B as intermediate vertex, because my starting is a matrix in which there are values with A as intermediate vertex. So let's see what happens if I want to reach from A to A via B. Can I do that? For that, first I have to go from A to B and then back to A. So A to B is possible because it's a 1, but B to A is not possible because it's a 0. So I really don't have a path from A to A right now via B. Then can I go from A to B? I really don't need a path because it's already a 1. So I'll just write 1 as it is. Now can I go from A to C via B? For that, first I have to go A to B, then some way to reach from B to C. For that, do I have a path from B to C? This B to C is a 0, so I cannot reach from A to C right now via B. Next, do I have a way to reach from A to D via B? So you will see that A to B, right now A to D is not possible, but with B I can really go. So first A to B is 1, B to D is also 1. So this is my first finding in this iteration. So I have found out a new path from A to D. Next, can I go from B to A via B? For that, I have to go from B to B, then B to A. Since both are zeros, there is no way I can go from B to A. So this value is a 0. Can I go from B to B via B? For that, I have to go from B to B, again B to B. Since both are zeros, there is no way to reach from B to B via B. Next, I try to see, can I go from B to C via B? For that, I should go from B to B, then B to C. So B to C doesn't really look like there's a way. So this value becomes a 0. Then from B to D, there is already a path. There is already an edge. So I don't have to find a path. So I'll just write 1 here saying that there is already an edge. Then I have to go from C to A via B. So can I go from C to A via B? For that, first there should be a way to go from C to B, then B to A. C to B is 0, B to A is also 0. So I cannot go from C to A with B as intermediate vertex. Same is the case with C to B, because to go from C to B, I should go from C to B and B to B, which is both are zeros. So this becomes a 0. Then can I go from C to C via B? I mean, it really doesn't look like I can go, because from C there are no outgoing edges. So C to B is a 0 and B to C is also a 0. So this value becomes a 0. So I cannot go from C to C. Can I go from C to D? For that, I have to go from C to B and B to D. So C to B is 0, but B to D is 1, so it doesn't matter. So this becomes a 0. Now D to A, we have already a directed edge, so we don't want B in between. So this value, simply we will copy it as 1 from here. And D to B, we have found out a path, so we don't want a B with an intermediate vertex. So there's already a 1, so we write as it is. Then D to C is also a 1, because there is a directed edge from D to C. So I'll simply write a 1 here. And now, can I go from D to D via B? For that, there should be a path from D to B, which is a 1. Then B to D, which is also a 1. So in order to go from D to D, previously I did not have a path, but now I have a path. So I go from D to A to B, and then B to D. So this is my second finding. So I will write a 1 here because I have found out a new path from D to B. So during second iteration, I have found out two paths, that is A to D, going from A to D via B. So I go from A to B, B to D. And the second finding is D to D. How do I go from D to D? D to A to B, B to D. So I found out two paths, and this R2 becomes an input for the next round, that is with C as intermediate vertex. Can I find a new path? Now, to find a new path from a new vertex, it should have incoming edges and it should have outgoing edges as well, because you want him to be an intermediate guy. So, but if you look at C, there are no outgoing edges. So ideally what will happen is the R2, if I take another of R2 and try to find R3, that is with C as intermediate vertex, I really don't have any new paths with C as intermediate vertex. I should not, because there are no outgoing edges. So instead of going through this whole step, I will simply skip, look at the first row and then, just write down all the other values. So to go from A to A via C, I should be able to go from A to C, then C to A. But A to C, no way of reaching A to C right now, and obviously there won't be a way to reach from C to A, so this value becomes a 0. Now for A to B via C, first there should be, there is already a path from A to B. I don't want to use C, so I'll simply write 1. Then for A to C, first A to C and C to C. Since A to C is 0, so this value becomes a 0. And for A to D, there's already a 1 here. So I don't want to use C as intermediate vertex. So this is already a 1, so I'll simply write 1 here. Same way, B to A, to go from B to A via C, there should be a path from B to C, then C to B, C to A. Since B to C is 0, this value will be a 0. So I'll just write down the values as it is in R2, because since C does not have an outgoing edge, C will never contribute anything. So this will be a 0, this has to be a 0, and BD is already a 1, so it will be a 1, and C to C will be a 0. This value again will be a 0, this value will again be a 0, this value will again be a 0. D to A via C is not required because this value is 1. So the last row has all 1s. So I just have to copy the last row as it is, because I don't, if there is a path already, I don't want to use C as intermediate path. So this becomes a 1. So this becomes a 1. This becomes a 1. And finally, this is also a 1. So what you see is R3, in the step R3, I don't find any new paths, so this particular matrix is same as R2. This actually happens because C does not have an outgoing edge, so C can never be an intermediate vertex to anything. So R3 is same as R2, and R3 becomes an input for the next step, that is to find a new paths with D as intermediate vertex. So R3 represents a matrix with paths from A, B and C as intermediate vertex. So if I use this as my input and use the same guy, a copy of it, and try to find R4, then R4 will contain all new paths with A, B, C and D as intermediate vertices. Now let's try to find whether I can find a new path from A to A with D as intermediate vertex. For that, I have to go from A to D and then D to A. So from A to D, there is already 1, means that I can go from A to D, and from D to A, you will see that there is a directed edge. So both are 1s. So this value obviously has to be a 1. So I have found out a new path from A to A with D as intermediate vertex. Next, from A to B, there is already a 1. So I don't have to find anything new here. So there is already a path, so I write 1. Now can I go from A to C via D? And let's see in the graph, you will see that I can go from A to D. I can go from D to C. So A to D is 1. D to C is also a 1. So A to C is possible. So this is a new path. Now for A to D, to go from A to D, there is already a path. So I'll just write 1 as it is because I don't want to use D again as intermediate vertex. So in this row, you see that I have found out 2 new paths. Now let's continue and see if I can go from B to A. Right now in R3 I cannot. So there is no way to go from B to A, but using D can I go? So if you look in this graph, B to D, D to A is possible. So B to A is possible. So to go from B to A, first I have to go from B to D, which is a 1. Then from D to A, which is also a 1. So both are 1s. So there is a new path from B to A. So I go from B to D and D to A. Now, can I go from B to B? Is there a way to go from B to B? So in the graph, you will see that B to D is possible and D to B is also possible. So B to B should be possible. So to go from B to B, first I go B to D, which is a directed edge, and D to B. D to B is a path via A. So both are 1s. So there is a possibility of going from B to B. Next, can I go from B to C? Right now B to C is not possible in R3, but from the graph it is very clear that I can go from B to D and D to C. So to go from B to C, first I go B to D, then D to C. Both are 1s, so this becomes a 1. Next, can I go from B to D? There's a direct edge from B to D, so this becomes a 1. So I'll just copy 1 as it is. Now to go from C to A with D, first I have to go C to D, then D to A. Now C to D there is no way, though D to A is possible. So there is no way of reaching C to A. So this value becomes 0. Now can I go from C to B via D? For that, first I have to go to D from C, which is not possible, though D to B is possible. So this value becomes a 0. Then can I go from C to C via D? So for that I have to go C to D and D to C. Now C to D is 0, so this value becomes a 0. So can I go from C to D, which is not possible because C to D is 0, D to D though it is 1. So this value again becomes a 0. Next, the last row I really don't want to use D as intermediate vertex because in previous steps we have already found out that there is a way to go from D to all these vertices because they are already 1s in R3. So I'll just copy these ones in R4 as it is. So D to A was already possible. D to B was also possible. So I write a 1 here. D to C was also possible. So I write a 1 here. And D to D was also possible. So I just write a 1 here. So this is my transitive closure of the matrix. We started with an adjacency matrix and we have reached this transitive closure. The values that are 1 indicates that you can go from the vertex in the row to the vertex in the column. So if B to C is 1 here, we see that B to C is 1, which means there is a path from B to C via some vertex or no, via at least one or more vertices. So this is the transitive closure. We'll try to do this R4 step using the algorithm itself. So this is the Warshall's algorithm. You will see that the Warshall's algorithm has 3 for loops. So we will try to do the last step using the Warshall's algorithm. That is, using R3, I will try to calculate R4. In the Warshall's algorithm, there are 3 for loops. So k goes from 1 to n, which represents the iterations. In our case, we are in the 4th iteration. So k will be 4 and I and j will go from 1 to n. And R4's ij will be a 1 if R3's ij is already a 1. Or we do the calculation. So if R3 has a 1, we should just write the ones as it is. For example, 1, 2 here is a 1. So we don't do any calculation. We simply write 1, 2 here. Or we do the ANDing of ik and kj. In this case, for 1 1, that is R4 of 1 1, I check whether R3's 1 1 is 1. It is not a 1. So what I do is, to calculate R4's 1 1, I use R3's 1 4 and 4 1, which will give me 1 1. So R4's 1 1 is R3's 1 4 into 4 1. Since both are 1, this becomes a 1. For the next step, first R4's 1 2, I check whether R3's 1 2 is 1. So since it is already a 1, I write 1 here. Next, I calculate R4's 1 3. So R4's 1 3, first I check whether R3's 1 3 is 1. No, this is not 1. So what I do is, R4's 1 3 is nothing but R3's 1 4, which is this, and it with 4 3. So 1 4 and 4 3 is nothing but 1 3. So both are 1, so this becomes a 1. And R4's 1 4 is same as R3's 1 4 because there is already a 1. So R4's 1 4 is same as R3's 1 4. So this becomes a 1. So similarly, if we continue ahead, we will see that this becomes a 1, and R4's 2 2 is nothing but 2 4 4 2, which is a new one, and R4's 2 3 is nothing but 2 4 and 4 3. This becomes a 1, and this was already a 1, so this becomes a 1. Similarly, if we keep calculating these values, we will get all our values for the third row, and for the fourth row you see that they are all 1s. So R4's value will be nothing but R3's value if it is a 1. So since all the values are 1 in the fourth row,